So generative AI makes apps truly intelligent. If we look at old applications, they have constrained interactions. They're hard-coded to fix to data sets, even though you can get dynamic with them, but not in the same sense. Change is costly and complex. Now we are moving into a world of intelligent applications where you have natural language interaction. They are data-driven, personalized, and continuously learn and improves from the user's interactions. So what are some elements of intelligent applications? Intelligent applications use pre-trained models. These are state-of-the-art pre-trained AI models that are easy to discover, customize, and integrate into new and existing enterprise applications. They are known for scalability and performance. They're able to handle high volumes of unstructured data in real time and from disparate sources. And they rely on app platforms that can scale based on the app's demand to ensure reliable performance. Simplify delivery. We have developer-ready environments to ship apps securely and quickly in their language of choice. And they enable frequent interactions by streaming costly and time-consuming apps. So some of these pre-trained models, like we all know by now, include models like GPT, DALL-E that can create images. Now we have GPT-4 with vision. Those models can enable scenarios where you can, for example, analyze an image and ask questions of the image. All right, so moving forward. Progressing from now to what is next. Traditional architectures and platforms are harder and unfeasible to adapt to these new opportunities. Traditional database struggle geographically distributed unstructured data and ensuring low latency access. This is something that Cosmos DB is fantastic at. App developers working in AI, data, and other products teams need unified experiences across environments that provide an easy integration between services and smooth transitions. So the CIOs recognize the foundation to support AI development must evolve. And that transformation, goes to clouds, apps, and includes AI. So what are some of these end-to-end application platforms for intelligence includes in our portfolio in Azure? We have, for example, the AI services. This is where you have GPT, Ada, the text embeddings, but you also have other services like document intelligence that allows you to extract data from documents and do OCR, for example, which is so important. It could be so important in some of these apps. Then you have a machine learning and AI Studio. Azure AI Studio is where we are now deploying the open source models and the small language models. And we have also a similar one called the OpenAI Studio, where you can do the same specifically with OpenAI models. From a database perspective, there are many databases in this environment, including Postgres, Cosmos DB, SQL, MariaDB, storage. The database story is also important when we are talking about building the kind of application that we are going to showcase, because the application that we are going to showcase is an application that relies on information that can be searched semantically. In other words, the user is able to type a question. We call those applications RAG pattern, and I will get into details of those applications. But we are also talking about something called vector databases, and I will talk about this in a second. From a compute perspective, AI applications are no different than other applications or cloud native applications. You will build your application and you need to decide the compute where you're going to run this application. So the compute can be Azure Kubernetes. It could be a web app. It could be AKS. It could be serverless with Azure Functions, app service. So the way that you build these applications and how you have options on how to deploy these applications. And of course, this includes the development tools and tools such as Visual Studio Code and GitHub Copilot and GitHub Chat. Azure API management, this is a very important integration service. I will talk about this in a second, but when we talk about scalability of intelligent applications, we have to remember that the GPT models are endpoints, and that the endpoints, REST endpoints, sometimes they may give you, you need to plan, for throttling and for latency. So you may want to be able to load balance across these services, and API management is the service where you would be allowed to do this. So what is a common platform with technology we need, right? Again, you have an application that you need to deploy to a compute. In this case, an intelligent application. That intelligent application can land on any one of our computes, and if you deploy it as a container, you can deploy it to any of the container technologies, and including, for example, Kubernetes, App Service, Container Apps, Azure Functions. Now, these applications in turn would use Azure AI services, and those in turn would use managed databases. So how can these applications deliver outcomes for your business, right? They can rapidly deliver new products that deepen customer engagement. Yes, intelligent applications are fabulous at doing that. Amplify the capabilities to empower developers to innovate. Yes, definitely. I think we see this in the customers that we work with. They all want to be engaged. They all want to build these applications, and the developers working with them are coming up with ideas on what they could do to improve the applications they have or build new ones. And scale your business and reduce risk for future-ready technologies, right? If you incorporate these technologies in the way you work, you may also improve the way that you operate your businesses. So let's move forward. So what is this realization of intelligent apps for your business, right? You can build new applications. You can add AI capabilities to existing apps. You can build your own copilots, which is what the session is about today. You can develop new cloud-native applications, and you can modernize existing applications. If you didn't know, Azure powers OpenAI and GPT. ChatGPT runs on Azure Kubernetes Service. It is backed by Cosmos DB, and it was developed and it's maintained on GitHub. And as we all know, ChatGPT is one of the fastest consumer products in the industry. This is one of the user stories that inspired me last year. When I read this story the first time, I was very impressed. And I think that's when I started doing some of the intelligent application development, specifically with this statement. This is a story about CarMax, and CarMax was using a scenario called content generation. So in content generation, you give it a product description, and then the system has to come out with a better description. Let's say, for example, you give it the car details, and the car details, the model, the color, and the sales price, and the intelligent application will generate a description. And if we look at this statement, it says the content team estimated that this process would have taken 11 years to generate this content in the same time that it took this application a couple of months to do. So, the outcomes of this generated massive amounts of original content, freed up additional staff. Again, we fear that just because these technologies may come and do some of our work, I see it in a way that, okay, well, we can now do something else with our time, something more valuable. And it also helped the car buying experiences for the customers through the AI innovation at lower cost. So let's talk about Copilot. So what is a Copilot? So in the definition of Copilots are intelligent apps that enable the use of natural language to find better and more relevant information. I would add to this that nowadays Copilots are extending this definition. A Copilot, like the one that I'm going to showcase, might have been made of one agent or one system responding, but a Copilot may be now a complex orchestration engine. So think of it as, like in the Windows Copilot, you ask it to give you the weather, and it will go and give you the weather. You ask it to run Notepad, it will come and give you Notepad. You ask it to give you a summary of a document. Maybe the only time that you needed a generative AI to answer any of these questions was when you requested a summary of the document. But the other times, it might have gone to a weather service. It might have gone to another service that says, "Hey, am I allowed to run Notepad on my computer?" Because running programs on your computer, you probably have to have filters that say, I'm going to let you run this, but not that, especially if it's someone trying to attack you. So what is the new development pattern, right? So conversational UX that attaches to your app and uses modern AI to assist with complex cognitive tasks, that's also Copilots. So in the new development pattern, we have the developers that can build safely, responsibly, and cost-effectively to avoid burden of building from scratch. The architecture, use pre-built hosted foundational models, customize them, or bring your own, like, in Hugging Face, GitHub, a new open source model. Will be used broadly, it can assist with security, search, productivity, operations. It can be industry specific. That's kind of what we are looking forward to. Now, how about the Copilots that Microsoft has developed? Microsoft has developed many Copilots, including Bing Copilot, the Office 365 Copilot, the GitHub Chat, and GitHub Copilots. And as we all know, I mean, if you are using these Copilots, it is truly a game changer. It is making us very effective in whatever area of productivity are, be it development, be it, imagine going into a Teams meeting and getting a summary of that long meeting, or going to Excel and having Excel analyze a corpus of data and saying, hey, what is the best product in my data, or in Bing, where, I will talk a little bit about the foundational concepts of these models, but as foundational models, they can learn new data. So if you are able to tap into new data, you don't need to worry if the model was not trained with, if you was trained with older data. I will talk more about data, but think about Bing. You type a query, it will try to find the latest and more relevant information and provide you the answer from that Copilot. So, the idea is to try to bring these Copilot experiences to your business. You can definitely create these Copilots for your own applications, and where you empower your customers and your employees. And just think about, where could you have a Copilot? So this is where I'm going to stop for now. Before I get into architectures and before I get into demos, I want to stop here to understand some of the foundational concepts related to building these applications. These are very key foundational concepts, and I have intermediate concepts. The first concept is, of course, the models themselves. You have GPT models. You now have GPT vision. Within the GPTs, you have the 3.5 turbos, the 4.5 turbos, the embedding models. But what are these models, right? These are, from a development perspective, these are API RESTful endpoints. You call these models via a REST API, you send a prompt, you get a completion in most cases. My point to this, why am I stopping here and why is this important? I think the first time that I wrote an application with these foundational concepts, I didn't even use any SDKs. I just looked at the API definition and said, okay, well, this is what I need to do. This is what I need to send. This is what I need to get. You can do this with curl. You don't even need an application. But quickly, very, very quickly, I started understanding that yes, maybe that's not really all that I need to know. So I also delivered trainings to my team of engineers, and in the process of delivering these trainings to my teams, I came up with this. I don't want to call them rules, but let's call them ideas that I think are important. So the first idea is, well, it's easy to send a prompt for completion. What is difficult is the everything else. So if you imagine that, yes, you have a GPT model, the GPT model, you can send a prompt and get a completion, and I'll talk about prompt completion in a second. It's very easy, but where is the difficulty, right? You can say, what is the speed of light? And the system will come back and tell you, well, the speed of light is XYZ. That's, by the way, that's always the demo that I use. And but then showcasing this in a way that makes sense, right? Putting a UI together, using a database, building a web API that actually enables some functionality. All these things that go behind building this application, you need to take into consideration. Then the next foundational concept is tokens. A token, by definition, is 75% of an English word, or 100 tokens equals 75 words. And in other languages, such as Spanish, Portuguese, Greek, the accented characters count as tokens. And why does that matter? You may say, Alex, but why is that important? Well, it's important because the cost of your prompts and your completions and the performance of your prompts and completions will depend on how many tokens you send in these prompts and these completions. So this is one of the key foundational concepts, being able to manage your tokens. And for that, I have two ideas or rules. And I have it, she or he who knows how to prompt engineer and stuff the prompt with context gets the riches. This is probably more down here, but she or he who knows how to manage the token counts gets to keep more riches. So the management of tokens is very important. So obviously, let's move down the foundational concepts of prompt and completion. The prompt is, what the user writes. The completion is the answer that the model sends. And why is it called a completion and not an answer? It's because, the completion is a whole payload of information. It's not only just the answer. It can be multiple answers. It can be the token counts. It can be arrays with images. It's a complex response. And obviously, prompt engineering is the practice of crafting prompts that effectively guide the AI models to produce the desired outputs. Prompt engineering alone, I have it as foundational concept, as intermediate concept, and as a very advanced concept. The process of writing prompts can be as sophisticated as writing a complex application. And the best thing that I can recommend in prompt engineering is to iterate over your prompts. I use the Azure playgrounds. I may give a prompt a context, and I will iterate and iterate over a prompt until I have it the way I want to. And that includes giving it samples, sample responses, sample output formats, a specific output format. Like, for example, if I want JSON. So that is on the prompt engineering side. On setting context, I think to me, this is one of the most important things that we can talk about. One of the topics that I talk to a lot is around, okay, the models were trained. These are the GPT models are generative AI models. As generative AI models, they're foundational models. As foundational models, they can solve many problems. What problems are we talking about? They can summarize, they can analyze, they can translate. They can, do recognize intent. I have a whole list of use cases, and I'm sure I don't have a complete list. So at the beginning, when a lot of the teams were coming and asking, hey, is it important that the model was trained with data in 2021? Is this going to affect me? And the answer to the question is no, not really. If you think about what the model is doing, a model learned to do these things. So it is the same as if I wake up in the morning, I haven't read the news from yesterday. I wake up in the morning, I look at the news or I read the news, and I am up to date, right? I am able to analyze, to interpret. So if I am able to give this to the model, can the model translate it? Can the model use it to, to recognize intent, to translate? And the answer is yes. So I have not rule number 4, idea number 4, the power of GPT model is not in what they know. The data can be outdated or unknown. It is in what they learn to do. As foundational models, generative AI models are trained to analyze, translate, summarize, generate text, etc. You can think of a model as a foundational model that can perform many tasks and operations. This is probably in the more advanced idea, but a model can also be its own little database that you can use it to answer questions. So and you can use it I think of it as a state store. Well, I give it some information. Somehow it has to know that you're giving it this information and that it can reuse it to answer your question. So the moment that you start thinking this way, I think you get more power out of these prompts. All right, so that's in setting context and and then if these are REST APIs, can you write an application without SDKs and orchestrators? And the answer is yes. Actually, the first applications I wrote, they didn't use any SDKs, didn't use any orchestrators, and then later started using LangChain, semantic kernel, and all the other APIs that are out there nowadays. So I wanted to give you your first demo of with this foundational level ideas. What kind of application could you develop? This is an application that I developed about a year and a few months ago, and there is a very famous website online that where you can go in and you can find information about future travel. And I wrote this application again just using REST, and I said, well, can you create a travel guide for Rome, Italy? So what this guy is doing, the prompt, and by the way that I wrote this application some months ago is that the prompt, I used to break it into little pieces and you could build the website very quickly. But now I got smarter with my prompt engineering and with my cost. And I said, well, instead of doing that in many pieces, let's just have the prompt return the entire payload for me. And again, if you think about this application would be very difficult to implement. I mean, it really, you would have to have a person almost in every country that is very familiar with the locations, with the attractions, with the food, everything, to build this kind of application. Anyways, I'm going to move forward with the intermediate concepts. So in the intermediate concepts, you have LLM and chat models. In many documentations, you will see, well, you know, some people refer to an LLM model like a question and response, and a chat model, one that can keep a conversation history. Why is the conversation history important? Because let's say, for example, I live in Miami, Florida, and I ask the model, hey, what are the top 5 restaurants in Miami? And the system will come up with the top 5 restaurants. And then I say, can you give me 3 more? But I don't say the city. I don't say, you know, I don't say I live in Miami again. How does it know that I am referring, 1, to restaurants, and 2, that I'm in Miami, and, you know, that I want more? It's because we are keeping a history of that conversation. So when we send the prompt to the model, we are also sending that conversation history. So it will say, user, what are the 5 restaurants in Miami? It'll come back from the assistant. Assistant, these are the 5 restaurants. User, what are 3 more restaurants? Assistant, these are the 3 assistants. So that's how this is working. Okay, so embeddings. Embeddings is a very important intermediate concept, which we'll be looking at very closely in a demo. This is a vector, an array of numbers that represents the text as a set of numbers. So the official description says an embedding is a vector of floating point numbers. It is the distance between 2 vectors measures relative to their relative relatedness. All right, so we will talk about what they do in a second. And then we talk about vector databases. And in Azure, we have, you know, Cosmos DB, Postgres, Redis, AI Search. And let's talk about resource augmented generation. This is the demo that we are going to see in a second, but this is an architecture pattern that basically allows you to put documents in a vector database. You embed those documents. So basically you turn those documents, the text of those documents, into embeddings. You put that text with that embedding in a vector database, and now you can perform a search, a semantic search. And then when you want to ask a question, you could say, well, go and find me the pieces that could answer that question, put the pieces together, and use those pieces to answer that question. And we will see this very slowly in the demo and in other samples, but this is what the RAG augmented generation is doing. Nowadays, we have something called Assistance API, and Assistance API can do, they can, like for example, Assistance APIs can maintain a chat, a thread history, the conversation history. They can do resource augmentation. They can do chart generation. They can do analysis. We will see this in a second. But, you know, it is, the assistants come with a bit more functionality that you could do anyways in your applications with the GPT models. All right, so with that, let's move into what are we showcasing today. So we're gonna look at a GPT-like interface application that is going to let us find product information. The interaction will be by asking questions and having a conversation. We require, fast performance. We require it to connect to our existing business data. And we require it to manage the conversation history. So the moment that you hear that, you know that we are using a chat model, and manage the store and search in the results history, similar to what they do in ChatGPT. Now let's take a look at this architecture. This architecture in Azure starts by a user submitting a question. Well, actually, it starts before that. It starts here. The first thing you need to do is you need to take your data and put it in a database. Once you have it in a database, you need to go through an ingestion process so that it can be used in intelligent application. So the data by itself in a database is not the one that you're going to be looking for. You can do that, and I will show an advanced demo of that. But really, what you're looking for is the content of your data. So what's going to happen is you're going to put the data on a vector database, in this case Cosmos DB, and you're going to go through a process of ingestion where you're going to take the data that is in this database, and you're going to break it into pieces. That is called chunking. The process of breaking your data into pieces, and you're going to send these chunks to cognitive search. So now what ends up happening is, let's say a document, and I'll show this slowly in a second. A document is broken into 3 chunks of 500 tokens. By the way, I'm not using characters, I'm not using words, now I'm using tokens. I have a text that is split into 3 500 chunks. We put them into cognitive search, and they're ready for them to be searched semantically. So the user asks the question, hey, what are the top products being sold? The question itself becomes embedded. The question that the user asks itself becomes embedded. And that embedding gets compared against the embeddings in the vector database. And in AI search, we get a little bit more fancy. We have something called semantic ranker that includes both the vector and keywords, for example. But to keep it simple, let's say that we are comparing vector to vector using something called cosine similarity. And then the system is going to come back and say, okay, these are the pieces of content that could answer that question. And you can tell it how many pieces you want to use. You can say, well, I want 1, 3, 4. And there's also the concept of relevance. Which of these pieces is closest to the question that you are asking. So you can increase or decrease your relevance. And then once you have the pieces with the relevance, the answer gets the entire the pieces of text, not the vectors, the text, get added to the context of the GPT model, and that model is sent on to GPT for final, let's call it final processing, the one that'll give you the answer. So what are the components that we have here? We have a compute, we have an application that is sitting, that is the one that, this is going to be your API holding your RAG pattern application. You obviously have Azure OpenAI. These are the ones that are generating your embeddings from those pieces of text. You have cognitive search. Cognitive search is acting as your vector database, not the database where you're storing the source documents. And you have OpenAI, which is doing the completions. So we are also using Cosmos DB to keep track of that conversation history, and so that we know this user typed this question and it got this answer. So again, what are the hero products here, right? Azure AI services. This is where we store the chunks and the embeddings. And this is where we perform the search, the near search, or the however you want to call it. This is Azure Cosmos DB. Cosmos DB is where we store the original data. And by the way, the input to Azure services can be anything. It can be a storage account. You can do it from programmatically, or you can just point point it to a database, and then it will automatically do it for you. And then where are we running this application? Well, if you are deploying the application using containers, you have the option of deploying this application to any of our Azure container technologies, the hero solution, of course, being Azure Container Apps and Azure Kubernetes Services. How about the development? I would say, that almost every language, because they are RESTful endpoints. Again, keep that in mind. If you're a developer, these are RESTful endpoints. But of course, the SDKs, the orchestrator, the lang chains, the semantic kernels, they are written for certain languages. But if they were not available for those languages, could you do it? Yes, you can. All right, so now we'll get to the demo. And I am not going to repeat this diagram because I went into details. But let's take a look at what this application looks like. So this is the application when it starts. I'm going to create a new chat. So let's think about what happened here, right? I created a new chat. I really haven't asked any questions, but this went to Cosmos DB, and it started a conversation thread. It has my ID. It has my conversation history. This is a brand new application for me. Let me increase my screen just so I see it better. And I don't know what to say. So I'm saying, what can I ask for? It says, okay, you can ask information about products, product categories, customers. Okay. What are some bike products? And it gave me a list of products. Anyways, this is great. This is keeping again the history of my conversation, right? But I could start a new chat, and as you can see, I start scratch from start. The other thing that I want you to notice here is that it's giving me the tokens that it used, and I can also view the prompt. This is very good for debugging, right? If I wanted to see exactly how this prompt is being formed in this application, and I think in most of the applications that we develop, we try to have a debugging window where we can see what is going on. We can see the prompt that was sent for completion. And this is actually a very good learning technique, prompt engineering technique. If you were ever wondering, hey, how do I become a better prompt engineer? Take a look at the prompts that are being generated, at the context that is being given to this guy, right? So this guy somehow it received this content from the embeddings. So our team has developed an application called RAG Commander. And I think RAG Commander is better to understand the intricate details of what is going on in a RAG pattern application. Here we have two files related to HR. The moment that I press chunk, it's going to take the token limits that I am giving it, and it's going to break those files into pieces. The next thing that I will do is I will embed those. And as you can see, I wanted to see what an embedding is. An embedding is just a list of numbers, floating point numbers that represent the content that is in this little chunk. So these files were broken into two files, file 1 and file 2. They were broken into seven pieces. Now, if I ask a question, in one paragraph, what are some company benefits, but I only ask it to use two results. Actually, let me make it more dramatic. I'm only going to ask it to use one result, and I am going to lower the relevance. In other words, I'm going to say, hey, I only want you to use one result, but the relevance, how close this embedding will be to this question, has to be above 0.7, and I am going to submit that question. And I get this answer. It actually tells me, hey, you're only out of the 7 chunks, you're only using 1. So let's change this to say now let's use 3 and try it again. If you notice, I don't have to read the answer. You notice that the size of the response starts getting longer and longer, right? Because now I am using a lot more content in my prompt window to answer that information. So let's do 75. Let's do 5. Actually, let's change the relevance to a really high relevance. And even with a high relevance, it still is able to find 4 pieces of content that could answer that question. And again, this is exactly what this application is doing, except that this application is doing more. This application, we've already loaded, instead of this application being 2 text documents, it's every item of our inventory, every customer on in our customer list, every product category, every, it has been embedded into a vector database. And because it's embedded in a vector database, we are now able to answer these questions. The other thing that this application does is that it can keep the history of this conversation, right? So here's keeping, what are some product categories? Who are what are some of our top customers? Right. So up here it says that he has information about customers. The customers from. Okay, Victoria, it gave me some answers. So I hope that you get the point with this application that the architecture, right? Let's talk about the architecture. This application is running in Azure. It's running as an ACA container. The backend is the backend is Cosmos DB. Not for the documents, for the actual data or the actual application data, and then AI search is being used to store the chunks and the embeddings that are answering those questions. So in that sense, this application is exactly the same as the one that we have on our architecture diagram. Now, I want to take you through a journey of sorts. If we look at this application, this Copilot application that is answering questions, how would we start our journey, right? Our journey starts with, well, maybe we have an application that doesn't have any intelligence. And maybe it looks like an application that can query our data, and we can sort our data, and we can look at data, and we can maybe perform some queries. But, can we do better? And the answer is yes, we can add chatbot, right? Chatbot is the same as this application. The difference between this application and the chatbot in this application is that right now this application doesn't have the concept of a chat conversation. But I could say, something more sophisticated. Write a demand letter to the customer with the highest balance. And let's take a look at what it does. And let's take a look at what it would require for the prompt to answer this, right? So basically, we would have to find the customer with the highest balance. So that's one analysis. Then we are using the generative AI capabilities of a GPT model to generate a nice letter. And we are adding context because our GPT model doesn't know anything about our products. So adding context is the same as going to that vector database, finding the little pieces of the chunks, putting it in the prompt, and using that context to answer that question. And this is taking a little long, but let's see. And let me run this. Okay, so here we go. So basically, it generates a letter, and I know that this person is the highest because I can see it here. If I go to top customers, I have them sorted by amount, but I can see that this is the context. So what could the next chatbot look like, right? On the next one, it's actually going to do something different. I'm going to say, what are the top 5 products? Now, this one is going to use SQL bot. SQL bot is different. SQL bot will actually try to generate a SQL statement and will execute it for you and present the results in a window. So here we see SQL bot, and we see the updated information. Now, the next level, I'm going to show Assistance API with the multi-agent, but so that you see what is the next iteration of these models look like. I started by saying that copilots, yes, copilots can do amazing things and they can answer questions. But a copilot that more sophisticated copilots will understand intent. So if I say, for example, what is the speed of light? It has nothing to do with my company. It has nothing to do with anything. But in my multi-agent mode, I have a system that says, hey, if you don't have a system that can answer this question, try to answer it using the default agent. If I say, what are some customers in the United States? I'm going to say list. So what's going to happen here is that the multi-agent has logic that says, okay, well, if the user wants to ask a question related to customer products, do this. If the user wants to write a query, so I will showcase the query in a second. Actually, let's run them side by side so that we don't keep waiting. And I apologize, I have this in like a very low-end hardware running right now, but like if I go to multi-agents and I say, write a query to find the top products that have bike in them. Let me see. Let me put this side by side. Now, if you notice, the multi-agent was able to say, well, this time the user is asking for a query. This time, actually, this one, I asked it to do I asked it to list some customers in the United States. This was my original query. This demo, I had left it for you guys to see. This is the Assistance API. I asked the Assistance API to create a graph of the total sales by country. And Assistance API, using it, it replied and gave me, it creates a graph of that information for me. So Assistance API is able to do analysis of data, generation of graphs. It has a tool called Code Interpreter, and Code Interpreter can actually write up a Python application, execute that application, and give you the result. So it's very powerful. It can also do function calling. So, for example, it can call functions that are part of the prompt. So that is function calling. So here you see the two kind of actually in multi-agent mode. I'm just going to do something simple, create a graph of y is equal to x squared, where x equals -5 to 5. And again, I apologize, but I have this running on very, very low hardware right now and taking a little longer. But so that you guys get the point out of this. So here you can see, you can see the evolution of how intelligence can be added to an application at different stages. You've seen it, working as a standard cloud native application deployed with Cosmos DB, deployed in this case is Azure Container. They say Azure Container, I forgot, I remember in a second. But you see the effect of, what happens when we are doing RAG pattern. What is it that is happening with RAG pattern? And a lot of the conversations we're having with customers related to RAG pattern have to do, how do we improve the quality of our responses? And in improving the quality of the responses, a lot of our answers have to do with taking control of ingestion, looking at the number of tokens, looking at how many what is your relevance, how many chunks are you using in your answer, at the quality of the source documents. Do you have PDF documents, and those PDF documents have a lot of tables? How are those tables being converted into text? If you're using images, how are you getting the text from those images? And let me see if this one finished. Up. Well, so this assistant is still in preview, but right now it gave me an issue saying loading the chat. But you get the point. It can do that. Anyways, back to the presentation. See. All right. So the next slides are just kind of in case the demo didn't work, but you guys see the Copilot working with some of these demos. Again, if you want to try this demo, I am going to leave this on for a little while, and But again, if you are taking next steps, let me finish here. If you are taking next steps, what are some of those next steps? Well, you could have an envisioning workshop. Think about the data that you want to connect and think about the possible outcomes. As a matter of fact, I would say that almost every intelligent application that our team has started, we always look at the input, the desired output, and then we iterate with the prompts in the middle. So before even an application is written, we may be testing, the context. Where is this data? What is the quality of this data? What kind of questions are we are expecting the users to be asking? And I didn't show you this, but a copilot doesn't have to be a copilot. In other words, it doesn't have to look like a box where you enter something. There are copilots that turn on and off lights. There are copilots that manage your Kubernetes clusters for you. There are copilots that manage your Azure CLI for you. And these copilots, they don't look like a copilot that has a chat box in it. All right. And with that, I think I am ready to take any questions that anybody may have.